Hi everyone. In this video, we will fit a negative binomial regression model. Compare this model with Poisson model with respect to estimated coefficients and the estimated standard errors. So first, we will import the libraries that are required. Import states_models.api has sm, import pandas has pd, import numpy has np. Then we will download the data. We'll use the separator equal space. When we print the data types, we see that 3 of the columns are of int 64 and 2 are float 64. Now looking at the Pashtun column, we see that it's all zeros. Looks like it's in levels. So let's check the levels of Pashtun column. df square bracket Pashtun comma dot unique open and close bracket, and the levels are 0 and 1. And then we will change the data type to categorical. This is how we do that. pd dot categorical bracket df square bracket Pashtun comma categories equal levels comma ordered equal false, and print the data types. The data type of the Pashtun column is category. Then we fit the negative binomial model. So to fit the models, we need the independent and the dependent variables. So the dependent variable is incidence. Because it's one column, we will use one pair of square bracket inside df. And to create an array of independent variables, adding a constant column, so capital X equal sn dot add underscore constant bracket df and double square bracket. This will create a data frame of calories, comma Pashtun, comma troops. Prepend equal true. So when we check the first 5 columns, so we see the constant column is added and we see the 3 columns are added. Then we create negative binomial model and we fit the model and we look at the summary. So this is how we do that. sm.glm bracket y comma x comma. We'll set our offset, and offset is np.log bracket df square bracket pop comma family equal sm.families.negative binomial, and then we fit this model. And when we print the summary, this is all printed. We will concentrate on comparing coefficient and standard errors. Then we will fit the model, Poisson model. So this is how we do that. sm.glm of y comma x comma offset is np.log bracket df square bracket of comma family equal sm.families.Poisson, and we'll fit the model, and then we'll check the summary. So these are the coefficients and standard errors being printed. Comparing the negative binomial regression model to the Poisson model using coefficients and standard errors, we see that the coefficients for intercept, which is given by constant here, calories and Pashtun all have the same signs. Has if you look at the sign of the coefficient is negative plus plus, and here negative plus plus, but are somewhat different with respect to magnitude. So you can see the magnitude of this is minus 4.0973, 0.0078, 1.9784, and here we have minus 4.8295, 0.0260, 1.7997. Estimated coefficient for troops. Estimated coefficients for troops is not significant. So we can see that troops, the coefficient, and looking at the significance of it, which is the p-value. Now here, all the coefficients are uh, highly significant for the Poisson model. Let's check for negative binomial model. So when we look at the negative binomial model, the p-value for troops is 0.474, which is quite high value when at 5% level of significance. So for the coefficient for troops is not significant in negative binomial model. For all coefficients, the estimated standard errors are higher for the negative binomial model, and which results in higher p-values. So look at the p-values. So here we have standard error for constant 0.108, calories 0.003, Paston 0.091, and troops is 2.32 exponent minus 5, and the p-values are 0, 0.008, 0, 0.002. And when we look at the negative binomial model, we see the standard errors are higher than what we saw for the Poisson model, and which is 0.525 for constant, 0.014 for calories, and for Paston is 0.394, and for troops 0 is almost 0. So the probability is, the p-value is 0, 0.071, 0.0, and 0.474. So for calories and troops is bit is higher.